Hello dear students, welcome back to Rouser's class. In the previous class we just finished about Werner's theory and we discussed some IIT questions or PMT questions based on the topic. So just go through the playlist, you will get that video. So that is one of the important topic. Now today we are going to learn about basic terms. We are going to learn about basic terms used in coordination compounds. So today's topic is what are the different basic terms that are being used in coordination compounds or coordination chemistry, right? So yes, we begin with this video. So before we begin that video, I'd like to ask you people, if you are not subscribed to my channel, please subscribe and please give some feedback or comment or whatever you like. Right, so yes, coming to the topic now. First of all, we directly go to the definition, means we go with some example. I take very simple example, K4FeCN6. This is a very common compound which is being used in chemistry. So especially coordination chemistry, its compound name is potassium ferrocyanide. Right, in this compound, this metal iron, this is called as central metal. That is called as central metal atom or ion. Central metal atom or central metal ion. What it will do is it accept the electron from the neighbor groups. So which means it accept electron pairs from neighboring groups. That neighboring groups are called as ligands. So that is ligand. Now any species which accept electron pair, and what we learned about that in lower classes, that is called as Lewis acid. So central metal act as Lewis acid. Now what about this one, this CN group? This group is called as ligand. The CN group is called as ligand. So ligand, what it does? So here iron is accepting electrons. So CN group will donate electrons. So it means they donate electron pair to whom? To central metal. They donate electron pair to central metal. So they are donating electron pair means they all behaves as a Lewis base. Understand this. So this one iron is called central metal and CN is called as ligand. Now the combination of central metal and ligand, whichever the group which is present in bracket, that whole group is called as coordination entity. The whole group is called as coordination entity or coordination sphere. Both names are being used. Now we learned three words. One is central metal which accept electron pairs, and next word is ligand which donate electron pair, and the combination of central metal and ligand is called as coordination entity or coordination sphere. Now what about this one which is presenting outside the bracket? Here potassium is presenting outside the bracket. So the group which present outside the bracket, that is called as ionization sphere. It is called as ionization sphere. So totally four words are there: central metal, ligand, coordination entity or sphere, and ionization sphere. These words are being used in this topic. Now, so here I'll tell you, when this compound is dissolved in water, what happens? Yes, you guess what will happen when this compound is dissolved in water. We studied in the previous Werner theory. This group does not get separate. Only the ionization sphere gets separate. How many potassiums are there? It is a 4 potassium groups which are getting separate. If 4 potassium groups are getting separated, then it is going to be FeCN6 4 minus. FeCN6 4 minus. This is about basic terms or the terminology used in this one. So now to make it more understanding, I'll tell you this how it exists. This is the big compound K4FeCN6. That compound, we can draw the structure like this. It is a central metal and surrounded by 6 cyanide groups, and these 6 cyanide groups are donating electron pair, so which means they are forming a coordinate bond. They are forming coordinate bond. So the coordinate bond will be like this, right? 6 coordinate groups. So cyanide groups 6, and now here the overall charge is how much? Overall charge is 4 minus, and here there are 4 K plus ions. So this is the whole structure, and here it is very clear that this iron is a central metal which is accepting electron pairs. This cyanide group is a ligand which is donating electron pair, and this group, whole group, is called as coordination pair, and this group is called as ionization pair. I hope you understood it, correct? Now I'll give you one more example. Some students ask, sir, give me another example. Yes, I'm giving you another example. So here you have to identify what is central metal, what is a coordination pair and all. CONH3 5 times Cl2. This is the one compound. Now in this compound you identify what is a central metal, what is ligand and all. Yes, first of all, cobalt. Cobalt is central metal and it is accepting electron pair from groups, and these both groups, ammonia and chloride, these both groups are called as ligands. Ammonia and chloride, both groups are called as ligand, correct? And what about this one? The whole group is called as coordination pair. Coordination pair. The next one, the group which is presenting outside the bracket, this chloride one, this is called as, yes, ionization pair or ionization entity. Now what happens if this group is dissolved in water? Suppose if this group is dissolved in water, what happens, that you have to think. So 2 chlorine atoms get separate. Now what is left? CONH3 5 times Cl, and here 2 chloride ions are going out, so that's why the charge will be 2 plus, and there are 2 Cl minus. This 2 Cl minus is called as ionization pair, and this is called as coordination pair. If you want structure, you can draw the structure also. CO, cobalt is surrounded by 5 ammonia groups and 1 Cl groups. They all are forming coordinate bond. They all are donating one pair. So 1 chlorine and 5 NH3 groups, right? It is called octahedral structure. This is called octahedral structure. And outside this group, what is there? 2 Cl minus ions, 2 chloride ions, and the charge will be plus 2. So this is all about the basic terms. Understood this one? Yes. Now next one. Yes. Now next, here we are seeing the word ligand. So that is a very big word. It is not as simple as said. What we understood, what is the meaning of ligand so far? Ligand is an atom or group of atoms which donate at least one pair of electrons, at least one pair of electrons to central metal. So which means it must has to donate electron pair. So electron pair it is donating means it acts as of course you all know, that is Lewis base, and it has to donate electron pair, which means it must have electrons. It must have electrons means it must be electron rich. Electron rich means that is either neutral molecule, or negative ion, but not positive ion. So rarely positive ion is there. So positive ion is very rare, rarest of the rare case. This is very rare, exceptional case. So most of the case the ligand is which one? Either neutral molecule or negative ion. This is about ligand. So here it is said at least one pair. It means they can also donate more than one pair. That's why we classify ligands into many types. So ligands are classified into many types. First one is unidentate ligand. First one it is unidentate ligand. Yes, you must have guessed the definition. What is a unidentate ligand? Yes, which donates only one pair of electrons, which donates only one pair of electrons to central metal. So why it will donate only one pair of electron, that we will see. See, the donor site will be there, that each donor site will donate one pair of electron. So that means unidentate ligands are those ligands which contain only one donor site. So I'll explain what is one donor site. I'll tell you. So you see, yes, example, suppose you take ammonia. In ammonia, nitrogen is the donor site which is having one electron pair. So that will donate one electron pair. So this is called as unidentate ligand. So this is called a donor site. Like another example, H2O. Oxygen is having two electron pairs, but one site will donate one electron pair. That means ultimately water can donate only one pair of electrons. So therefore water is called as unidentate ligand. So like this we can call dentate. This is called as denticity. So many times CBSE asked the question, what do you mean by denticity? So denticity means how many number of electron pairs that it can donate. So the number of electron pairs that can be donated by a ligand is called as denticity. Or I can say the number of donor site is also known as denticity. So as I told, ligands are of two types, mostly neutral ligands or negative ligands, and very rare positive ligands are there. So I'm going to give you some examples with their IUPAC names. Like H2O, there are two electron pairs on oxygen, but it will donate only one pair because of rule one site can donate one pair. So this is called aqua. H2O is called as aqua. In IUPAC name. NH3 is called as amine. It is also unidentate ligand. Another example, CH3NH2, which is called methanamine. It is called methanamine. So I'm giving you the IUPAC names also, so that nomenclature can also be done together. Here, what is the donor site? Nitrogen is the donor site. So one donor site is there, therefore it is a unidentate ligand. Another example, C5H5N, that is the structure like this. Yes, it is a benzene ring with a N, that is called as pyridine. That is called pyridine. Next, CO. CO, carbon monoxide we call, and this is carbonyl group. In IUPAC nomenclature, we use the word carbonyl group. Next, NO. NO is a unidentate ligand which we give the name nitrosyl. These are the unidentate ligands, but which unidentate ligand? Neutral ones. Now, negative ligands, negative unidentate ligands like OH minus. Always the name of negative ligands end with, always the name of negative ligand end with O. So here OH minus, which is called, actually we call hydroxide, but here we say hydroxo. Like Cl minus, we say chlorido. We say chlorido. Br minus, we call bromido. So similarly, I minus, we call ido, not idido. We simply call ido. Then Cn minus, we call cyano or cyanido. Cyano or cyanido. The next one, SCN minus, we call with the name thiocyanito, and NCS minus, we call isothiocyanito. Isothiocyanito. NO2 minus, there are two names. First of all, let us learn nitrito, and we will see the names types also. Nitrito. O2 minus, we call with the name oxido. So like this, we will see many more negative unidentate ligands. But I said there are some positive unidentate ligands also. So positive ones I'll tell you, yes, after this. Now, positive ligands, I said positive ligands are very rare because positive ligands are electron deficient. So electron deficient means they cannot donate electron pair, but very rare are there. One is this one, NH2 NH3 plus. Here this is the positive one, electron deficient, but this nitrogen is a free, so it can donate electron pair. So this kind of ligand is called as hydrazonium. If you can remember, in organic chemistry, you must have studied hydrazine. What is hydrazine? NH2, NH2, that is called hydrazine. So hydrazine is a didentate ligand because the two electron donating sites are there. But here, this NH3 plus, so that's called as hydrazonium. Similarly, NO plus. So NO plus charge is there. So this is called as nitrosonium. This is nitrosonium. And NO2 plus, this is called as nitronium. So these are the very rare positively charged ligands, right? So this is all about unidentate ligands. That now the next one is didentate ligand. Okay, monodentate ligand, you have learned about it. Now it is didentate ligand. Yes, definition, what can you say? As the name itself, you must have got idea. Didentate ligand means which can donate two pair of electrons, two pairs of electrons to central metal. Yes, that is called as a didentate. Or else we can also give another definition, which have two electron donating sites. two electron donating site, that is also called as a didentate ligand. Yes, example. So when you see the example, then you will understand it more better. So here also again there are two types of examples. One is neutral ligands, the next one is negative ligands or anionic ligands. Negative ligands are also known as anionic ligands. Yes. Neutral ligands, one example is this very famous one which we use many times in this chapter, that is this one. Yes, tell me the IUPAC name of it. And here you see the electron donating site. This nitrogen is a one electron donating site, this nitrogen is another site. So totally two electron pairs are being donated, therefore it is called as didentate ligand. Its name is ethane 1,2 diamine. Spelling we have to see, it is not a double M, it is a single M, or it is also known with the name, common name, ethylene diamine. It is a common name, but IUPAC name is ethane 1,2 diamine, and the symbol we use here, it is En. The symbol is En. Similarly, we can have many other examples like this one. This is what? You know what is the name of this one? Pyridine or pyridine. This is another pyridine. So this is called a dipyridyl ligand, which is a didentate ligand. And here what are electron donating site? This is the one site, this is the another site. So this site will give one pair, this site will give another pair. So totally two pairs are donated, therefore it is a didentate ligand. Another example, yes, now you are going to give me the IUPAC name of this compound. You give me the IUPAC name of it. Yes, what is the name here? It is a 3 carbon, so therefore it is a propane 1,3 diamine. Propane 1,3 diamine. Its symbol is PN. Its symbol is PN. These are the example for neutral didentate ligands. Now some anionic ligands like oxalate C2O4 2-. This ligand is called as oxalate ligand, but we write oxalato because the negative ligand name end with O, oxalato. Now you may ask me, sir, show me the structure. So here its structure is C double bond O, O-, and another one C double bond O, O-. So here this oxygen is giving one pair of electron, this oxygen is giving another pair of electron, therefore it is a didentate ligand. So oxalato ligand, and the symbol we use here, it is OX 2-. Charge is 2-. So in this chapter many times you will see OX 2-, which means oxalato ligand. Another one CO3 2-, which we call carbonato. So structure, can you give me the structure of this one? Carbonato, C double bond O, O-, O-. So here this oxygen is giving one pair of electron, this oxygen is also giving another pair of electron, therefore it is a didentate ligand. So another example, SO4 2-, which is called sulfato, because actually we call sulfate, so end we write sulfato. And similarly SO3 2-, which we call sulfito. So these all are didentate ligand examples. Now last example here, it's a very famous DMG, which people call dimethyl glyoxime name, it's called a name, IUPAC name, we end with O, that's why we call dimethyl glyoxymato. Yes, what is the structure of dimethyl glyoxymato? Let us see. This is a very important one. It's one time asked IIT question also. The structure is dimethyl C double bond NO minus C CH3 double bond NOH. Right. So here this oxygen is a one electron donating site and this oxygen is another electron donating site. Totally two electron donating sites are there. Therefore, it is a didentate ligand. And very important, only one time asked IIT question. So DMG, dimethyl glyoxymato. Yes. Now next one. Third one, unidentate ligand over, didentate ligand it is over. Now it is tridentate ligand. Now I'm not going to give the definition of tridentate ligand because you have to guess it. So you know very well the tridentate ligand which donates uh, which can donate three pairs of electrons to central metal, or you can say which is having three electron donating site. As usual, we have two types. One is a neutral tridentate ligand, another one is anionic tridentate ligand. The neutral tridentate ligand is very rare example. We have only one example, this one. So you tell me the IUPAC name of it and you see the number of electron donating site. This is the one electron donating site. This is the another site. This is the one more site. Totally three pairs are there. Therefore, its name is propane 1, 2, 3 triamine. Propane 1, 2, 3 triamine, and we call simply PTN. PTN, that is the only neutral tridentate example. And anionic ligands, we have two examples. One is a PO4 3-, which is called as phosphate actually, and here we end with O, so phosphato. Another example, ASO4 3-, which is actually arsenate, so we call with the name arsenato. This is about tridentate ligands. Now the next one. So after tridentate, now we are not going to tetradentate. We simply call polydentate ligand. So polydentate ligand means which will donate more than 3 pair of electrons. Which will donate more than 3 pair of electrons to central metal. That is called as polydentate ligand. Now, the example for polydentate ligand is EDTA. EDTA with charge of 4-. Now, you may ask me, sir, what is EDTA? EDTA full form is ethane 1, 2 diamine. Ethane 1, 2 diamine tetraacetate. Tetraacetate. This is a EDTA. Now, what is its structure? So, ethane 1, 2 diamine, you know. Ethane 1, 2 diamine. Here, ethane and diamine 2 times N. Now, what is acetate? Tetraacetate. Acetate group, you know, it is a CH3 COO-. But carbon valency we have to fulfill here. That's why we will write not CH3 but CH2. CH2 COO-. And 4 groups because it's a tetraacetate. And this is called EDTA. So this is the full structure of EDTA. Many times board asked question, even JW also, IIT also. Which of the following is the correct structure of EDTA, like that they can ask. Now tell me its denticity. How many electron pair it can donate? 1, 2, 3, 4. 4 pairs? It is wrong. One more. 5 pair and 6 pair. Therefore, it is called hexadentate ligand. It is called as hexadentate ligand. But the charge on this is 4-. It is about polydentate ligand. Now, the next another word we use in this chapter is ambidentate ligand. So these are the different kind of words which we are going to use in this chapter. Ambidentate ligand. So ambidentate ligand, before I give you the definition, let me give you example. Example, it is NO2 minus. NO2 minus, if you see its structure, N double bond O, O minus. Here nitrogen can donate electron pair to metal, as well M oxygen. This oxygen can also donate electron pair to metal. So here in NO2, this is also NO2, it is also NO2, but the difference is here oxygen is donating electron to metal and here nitrogen is donating electron to metal. This kind of ligand which is having more than one donor site but binds through only one site, that is called as ambidentate ligand. Like you have two places to donate. Two places are able to donate electron pair, but at a time only one place is donating. So if nitrogen is donating electron pair, the name of the ligand is nitrito N. If oxygen is donating electron pair, then the ligand name is nitrito O. Definition, you can make the ligand which have more than one donor site but binds through only one site at one time, that is called as ambidentate ligand. So there are many other examples, you just go through that, and if you don't know you can ask me and I'll provide you in the next video. You can ask me in the comment box. Now next one, it is chelate ligand. So this is a very simple word, last word, chelate ligand. Chelate means, the word chelate is a Greek word which means cage-like structure. What is the meaning of chelate ligand? You see, here you take a didentate or tridentate ligand, like this one, ethane 1,2-diamine. Ethane 1,2-diamine. Now, if both the electron pairs are donated to only one metal, if both the electron pairs are donated to one metal, then a cage-like structure is formed. Then that is called as chelate ligand. So definition, what can you say? If all the electron donating sites of ligand donate to only one metal and form a cage-like structure, it is called as chelate ligand. You may ask me to give some another example. I'll give you oxalate also. Oxalate ligand, you know, its symbol is OX2 minus. If this oxygen and this oxygen, if these both are donating electrons to same metal, then it is forming cage-like structure, and that ligand is called as chelate ligand. So here all electron donor sites bind to only one metal to give a cage-like structure, that is called as chelate ligand. So these are the different terms which we use in this coordination compounds. So I hope you understood this one. In case if you have any problem, mention it in the comment box and share with your friends. If you have anything to say, share with me also, so that I can also improve. Thank you guys, and take care of yourself.
Subscribe now and press the bell icon. Never miss an update. Subscribe now and press the bell icon.